was going to talk about quantum physics, not as a scientist, but as a engineer and a practical person. And I wanted to talk about space-time and my ideas on the creation of the universe. That, I feel, is the best representation of our universe. And I wanted to talk about what actually is time. Every time that I look online, I keep seeing that they show a clock, and then they talk about relativity. And they talk about exactly what they measured. But, like, I think time is a little bit different than just a description. I think it's a ratio. Like, in other words, this match, to me, took only 3 or 4 seconds before it was extinguished. But in this event, there might be thousands times millions times trillions of things that are happening. You know, different elements being formed, the radiation of heat and energy, and an unsurmountable amount of different events took place. Well, if you compare yourself to one of those events in this chain of events, and there was enough of them, it would seem like time would be infinite. It would be like, wow, I can live here for millions of years and to no consequence of it ending. So I would say time is a ratio and a pairing to events. I never really heard that before. So then I have it here, time ratio, 1 second, 2 trillions, forward through events that must happen. The events must happen, then you're basically paired to those events. It would seem like an eternity. So now, I guess the next thing you talk about is, why is there time, right? And I think of time as a chemical reaction. So, in other words, like, say, as an analogy, you had a pot of water, and everything that we knew was in that water, and there was a source of energy that was causing it to change or boil, right? So what I'm proposing is that the nothingness of space is not nothing, that it is actually an extremely powerful energy field, and it interacts with matter. So that field is vibrating and is time. It's like the frequency of the universe. There's several things that you can call this. You can call it ether, or you can call it dark matter, which is the newer term. You can call it the fifth element, which the ancient people that didn't know very much called it. But there's also in there, they talk about ether as something different than matter. And as you go back further, so if you look back further, it seems to imply that it's just as real as what we consider to be physical. So I'm actually, my belief is that, let's say this is a solar system or an atom. This would be matter. But there is a fifth element that is in or interacting with the matter that you can't see, right? So I guess I can divulge a little bit on this. The Large Hadron Collider finding basic matter particles. You look at it and it's like, okay, I got all these matter particles, and then they tell you there's insufficient mass. There's no, like when you break an atom, the comparts that come out of it don't equal the same mass as when it was an atom. So something's missing. That constitutes mass, or constitute, I guess, what we consider to be matter, right? So my idea is that there's a large interaction, like this energy, that is part of space-time. It's basically space-time, empty space. It's basically something a lot more than looks like nothing. When you look at the sun and you look at an atom, both have a field around them. Like when you see then a picture of an atom, which they have, believe it or not, you know, it looks like a little round energy field. And when light shines at, say, the sun, from behind it, you can actually see a star behind the sun because the light curves around the sun. So you can actually see a little bit behind the sun, as Einstein predicted. So it seems to me that this fifth element, or vacuum energy, compresses matter, right? So it compresses matter. It compresses it also at the subatomic level, right? And then people would say, well, that creates gravity. No, it creates a bend in space-time, which creates a push. Like, there is no pull. There's a push. That's a very big difference between what I believe, or what I've come to believe by looking at the facts, that everything is pushed. So that would mean it's a crushing force. Like when you drop something, it's pushed to the earth. Just like the atoms are crushed, and just like the sun has the spent space-time around it, which is holding it, the matter. So if there's a push towards the center, that pushes everything towards the center, isn't there an equal and opposite push the other way? Wouldn't that describe the reason why the universe is expanding faster than the speed of light? If all matter has got this force that's a push, so one of the laws of physics is whenever there's an equal reaction one way, there's an equal opposite reaction the other. So that would mean that all matter would be kind of pushing apart. So that's an idea. So I guess the next thing I wanted to talk about the double slit experiment. How can you not mention that in physics? Since it's the most controversial subject in this stuff, the creation of the universe in this. Light goes through a slit, goes over here, makes an interference pattern. Well, the way I figure it is, light is a wave and a particle. Light is not part of an atom. A photon is created, and I think that this is an interaction between the vacuum energy and matter. Remember, the Large Hadron Collider can only see matter. Its sensors cannot